Good morning, everybody. Thanks for coming out. My name's Rowan Miller, and I work as a program manager on the Entity Framework team at Microsoft. You're here today, hopefully, because you want to hear about Entity Framework Core. Entity Framework Core is a new name. We haven't seen that at conferences before, so let's talk about what this thing has been called in the past. A couple of years ago, we put out a spec that talked about Entity Framework Everywhere, which was the idea of taking Entity Framework and making it run in everywhere that you would write .NET code. We decided that what we were building really felt more like the next evolution of Entity Framework, so we scrapped that name and went with Entity Framework 7, which is what we've been talking about for a couple of years now. The problem with this name is it makes it sound like it's the next version of Entity Framework, that it would have all the features from the previous version, that it would be more stable and more robust, which is not, as you'll learn during this presentation, the case. So since our last time here last year, we've scrapped that name, and we're now called Entity Framework Core, or EF Core 1.0. OK, so now we know what we're talking about. Our agenda is very simple. We're going to spend about 5 to 10 minutes in slides, just kind of setting up what EF Core actually is and what it's all about. Then we're going to spend almost all of our time today in Visual Studio writing code in demos. Obviously, we've been demoing EF Core, or EF7, for a while now, so I've got a fresh set of demos. This is stuff that I haven't shown before on stage. If you've sat through an EF7 presentation before, the slides will look familiar. Some of it has changed a little bit, so it will either be a refresher for you, honing in some of the things we've talked about, or if you haven't heard of EF Core before, it'll just kind of set up exactly what we're building and why. At the end, I'm going to walk you through some places you can head next to learn more about EF Core. Just to set expectations for what we're going to cover in this session, it's listed in the program as a level 200 session, and the introduction through slides is probably like level 1 to 200. Once we hit demos, we're going to range all the way from 100 to 300, perhaps even getting closer to 400, so there should be something in this talk for everybody. Also, just wanted to make clear we're not talking about EF6, which is our current stable release. This session is completely about EF Core, which is still in pre-release, so this is a look at what's ahead, not how to use what's already released. There's lots of great sessions and content out there about EF6, so you can go look at previous tech eds and ignites and builds for information on that. Just so I know who I'm talking to in the room, how many folks in the room have used Entity Framework in an app before? Any version at all? Great, that's what I expected, almost everybody. How many folks have played with EF Core? Anything from running a console app? OK, so we've got about maybe like less than 10% of the room. That's good. OK, let's talk about what EF Core actually is. This slide is to help you understand that for the last 8 years, we've been confusing our customers while we learn how to write and ship software. We started writing Entity Framework. What would you call V1 of your software? Of course, we started with 3.5 Service Pack 1 because we shipped in the .NET Framework 3.5 Service Pack 1. Now, obviously, one of the advantages of this, you install the .NET Framework, you have everything on your machine. The disadvantage, if we need to fix a bug, it takes a year to 2 years to ship this thing. And so if you hit something, it's a long time before that gets into your hands. Starting with EF 4.1, we started shipping the new stuff that we built out of band on NuGet, but we still had all of the core components in the .NET Framework, which meant we could fix and iterate quickly on some things, and other things we still had to wait for a rev of the full framework. This was also, of course, extremely difficult to explain to customers. So then we started in EF6. We bit the bullet, and we took everything, and we shipped it out of band now on NuGet. We also moved our tooling out of Visual Studio and put it on the Download Center so that we could ship both the runtime and the tooling quickly and increase the rate of innovation. At this point, we also went open source. Now, moving open source, I mentioned we've been confusing our customers as we learn how to develop and ship software. There is this great thing out there called GitHub where everybody exists and works on open source software. So, of course, what we did is build our own thing called Coplex, and we went open source on that. Entity Framework 6.1.3 is our current stable release, and later this year we'll be releasing Entity Framework 6.2. So the key takeaway from what I've shown so far is that this stream of Entity Framework is still going forwards. At the same time, our team is working on EF Core 1.0. And this follows the same development and ship methodology that Entity Framework 6 did. The big difference being that now, instead of being on Coplex, we're on GitHub where everybody else is. OK, now you know where EF Core kind of fits into the stack. Let's talk about what EF Core is all about. One of the things we want to do is target new platforms. If you were in Scott Hunter and Hanselman's talk yesterday, you would have seen this slide that kind of explains the current state of .NET. In the bottom right-hand corner, we have this runtime components box, and that's where Entity Framework fits. If I'm using EF6 today, then I only get the full .NET Framework support, which means I can do WPF, WinForms, full .NET console applications, ASP.NET, things like that. But we have these other new boxes that have come online in the last few years. And so with Entity Framework Core, will also exist down in this runtime components box. But the idea is that this works right across the stack. So whatever app model you pick, whatever part of the framework you're running on, you should be able to use Entity Framework code. Now, if folks have tried using our previews at the moment, you'll realize that this isn't quite a reality yet. Our current bits that we're working on our nightly feed don't actually run in some of these far side boxes in Xamarin. But this is what we're working towards, getting it running everywhere, and we should be there by the time we RTM with V1. As well as new platforms, folks are targeting a much wider range of data stores today. 8 years ago, most people were just targeting relational databases. Nowadays, non-relational is a big thing. And so we are architecting EF Core to allow you to use Entity Framework code to target non-relational data stores as well. Now, what we're not doing is building some magical abstraction that hides the type of data store, because that stuff would demo great on stage, and as soon as you try to use it, it breaks and falls down. So we're building a core set of components that make sense for most data stores, like, for example, using a link query to pull objects back into memory, tracking changes to those objects so that we can pass the change set to the provider and let it persist it. But then, of course, there's a whole bunch of stuff that's specific to a data store. So if I'm on a relational one, I want to configure the column and table name that a property maps to. If I'm on Azure Table Storage, I want to set the row and partition key for an entity. And that stuff is just handled by APIs that light up when you install a particular provider. And just here's some examples of stuff we've worked on. Now, not all of these are going to ship in V1. For V1, we're just shipping our relational providers. But we have also prototyped Azure Table Storage and Redis just as a proof of concept that the stack will work in non-relational stores. And then we do plan to bring those through to an RTM. They're just not going to ship on the same date that V100 of everything else ships. Should also mention we have an in-memory store, which makes testing, so functional testing where you want to run your app against a database, makes it a lot easier to do that. Not just running code in more places, targeting more data stores, we also have some new features. As we'll learn in a minute, EF Core, we basically have a fresh start here. And so some features that were very difficult to implement on the EF6 code base, we can implement right from the start in EF Core. I'm not going to go over these in detail now because we're going to demo almost every one of these. Under the covers, Entity Framework Core is built over a completely new set of components that make up the core of Entity Framework. We talk about this being lightweight and extensible. So it's a top-level API, so DB context, DB set, all the stuff you're used to, but built over a set of services that are put together as a collection. We use dependency injection to kind of wire up this very loosely coupled set of services. Now, the advantage of this is if you want to reuse some of our components, you can easily pull them out. So for example, if you want something that's going to tell you, given this CLR type, this would be the right data type to use for a column in SQL Server, you can reuse our type mapper. Or if you want to change it, you can derive from it, modify it, and then register it your own implementation in our DI container, and then we'll use that. And because these are coupled into small services that just do one single thing, it's easy to replace the individual little piece of functionality that you want to change. Obviously, all software should be built to be optimized for memory and CPU usage. Entity Framework 6 isn't great in this area. So from EF Core, we're building it from the ground up. This is especially important today. A, as we're looking at running on devices, because obviously resources are limited there. But we're also moving rapidly towards cloud computing. And guess what? You pay for CPU usage in the cloud. So if your framework uses less CPU, it costs you less money at the end of the month. And then the idea of pay-per-play just means that if I'm not targeting a relational database, I don't pay any cost for the relational components. The NuGet package isn't installed in my project. The assemblies are never loaded into memory, and I never execute any code. So we're trying to make things very modular so that you only pay the cost of the components that you actually use. OK, so now we know what EF Core is all about. Let's talk about how that relates to EF6, and then we'll jump into some demos. One of the mantras we've used as we've built EF Core is that we want to be mindful of our past. This thing is still called Entity Framework. So we're going to have the same top-level experience, still DB context, still DB set, We're not just going to go and change API names because we like a name better than we did a couple of years ago when we implemented it in EF6. At the same time, we don't want to be constrained by our past. Entity Framework 6 had a very monolithic kind of, I like to think of the code base as a big plate of spaghetti. You know, you try to move a meatball and a piece of spaghetti falls off the side of the plate over here, okay? So we have a new code base. Like I mentioned, this lightweight and extensible core, well, that's something completely new. And of course, being a V1 with a new code base, not everything that was implemented in EF6 is going to be implemented in EF Core. Some of it's just missing from the first release and will be added in the future, and some of the more obscure features that complicated the code base will just never be implemented on EF Core. So when we look at putting these two side by side, obviously EF6 is mature. It's been around for 8 years. There's a whole bunch of database providers. And we're going to continue working on this thing. Like I said, we have EF 6.2 coming out later this year. Don't expect any major releases with crazy new features in it, but we will do small features, small improvements, bug fixes, and of course, we're open source, so we take community contributions as well. EF Core is truly a V1 product. We have the basic feature set shipping in V1. It has some limitations, and we don't have a huge ecosystem of database providers as yet. But over the coming years, that will build up. Behind the scenes, we are actually working with a bunch of other database providers. Some of those are open source, and they've already shipped versions of their product. Other of those are more closed source, and they'll announce their plans for EF Core when they're ready to. So if I'm making a decision, which one do I use? Don't be afraid to go and choose EF 6.x. EF Core is a new thing. You might feel like you have to use the latest version, but you don't. EF 6 is mature. It's supported. We're going to continue shipping minor releases of it. If you're thinking about EF Core, make sure you do your homework on exactly what's supported in the current version of it. So like I said, there's features that aren't implemented yet, like lazy loading, or another huge one, store procedure mapping for insert, update, and delete statements. That stuff's not there yet. Obviously, that's critical, and we have to have it in the future. But we could hold off V1 and ship it next year sometime with all that stuff in it, or we could ship V1 with the feature set it has now, and then we'll add that stuff, and folks can move to EF Core when it has what they need. Also, some things just take time to bake. The link translator that takes your link query and translates it to SQL, well, that's been 8 years of continuous development in EF6, and it can handle crazy link queries. Like, we have people send us queries that don't even fit on your screen and wonder why parts of it don't evaluate correctly. EF Core, and why it's slow, not surprisingly, that turns into a big SQL query, right? EF Core, we've been working on this thing for a couple of years. The link translator is not as mature. And so you are going to hit cases where stuff's going to get evaled on the client, or it's going to give you an exception, and you have to kind of work around issues in it. So just be aware of these things. You really are opting into a V1 product. And then if you're looking at an existing app that uses EF6, you want to move to EF Core. It might still be called Entity Framework, but it is also quite different. So simple stuff with DB Context and DB Set will port very easily. If you're doing things like working with the metadata API, that code's going to take quite a bit more work. Your code should look a lot nicer after you've migrated, but it's not going to be a non-trivial upgrade. Should also point out, we are changing the behavior of some APIs. So you should just be aware of things like adding stuff to a DB set if you have disconnected graphs of entities. We've taken the opportunity to adopt a more intuitive behavior, but it's also different than what was in EF6. If you want to get familiar with the limitations, then on our wiki, we have a roadmap. And as part of that roadmap, we kind of have a section there that says, this is a set of critical ORM features that are missing from V1.00. So that would be good stuff to review if you're thinking about adopting it. All right, that's enough slides. Let's get into demos. Given that about 93% of folks in the room have not actually seen EF Core yet, I'm going to start with a very quick demo of a 101 EF Core application. It'll just highlight some of the differences between EF Core and EF6. If you've used EF Core before, you can check your email or Facebook for the next couple of minutes, and we'll get folks all caught up so we're all on the same page. All right. This is what a model looks like in EF Core. It looks exactly the same as EF6. I have a very simple class called an entity, which has properties with getters and setters, and this is what I want to persist to the database. Similar to that, I also have a context. It inherits from DB Context, and it has DB sets for each type in my model. Now let's look at something that's a little different. Instead of Entity Framework magically deciding what database it wants to use, and then me scratching my head wondering where on earth that thing is, we now have to be a lot more explicit in EF Core. So we override this onConfiguring method, and we get, you'll be seeing this class a bit today, DB Context Options Builder. And this thing lets me set up the options for my context. So one of the things I get is some use methods. If I just zoom in, you'll see that there's a use SQL Server here. That's an extension method because I have the SQL Server provider installed. And then I can pass in a DB connection or a connection string. Everybody knows how to type connection strings by hand, so I'll just drag mine in from the side there. The scary thing is I actually do know how to type those by hand now. OK, so now we have a context, but we don't have a database. Now there's kind of two ways you can use EF. You can either point it at an existing database and have the model generated for you. That works in the current releases of EF Core. There's no visual tooling for it yet, but in Package Manager Console and Visual Studio, you can say scaffold DB context and give it a connection string, and it will spit out a model for you. So as we have kind of moved to EF Core, we've said that we're not doing the XML-based designer anymore. And folks tend to freak out thinking that means we're only doing the method where you write code and then have the database created for you. And that's not true. EF Core will work just as well against an existing database, or you can have EF create and maintain the database for you. Now, I want to create the database based on my model. There's two ways I can do that. Migrations lets me create the database and then keep it up to date as I make changes to my model. But for prototyping, that's quite a bit of overhead. So instead of doing that, I'm just going to call an API that says database.ensure created. And that's just going to go and make a database for me that matches my current model. Obviously not something I would do in production, but while I'm prototyping away, it's great. OK, I've created an instance of our blog entity here. So we're going to say add. No surprises here. This is exactly the same as it was in EF6. And of course, we say save changes as well. And then query, again, like EF6, we're using links so we can pull back all the blogs from the database. And of course, I can do like order bys or whatever. So let's order by the name, pull those results into a list. And then let's just write out how many blogs came back from the database. All right, let's run the app. Now, when I run this, it's going to go away and create the database in the background, so it will just take a minute to execute here. The connection string I gave it said to connect to my local DB instance. So I've got that open in SQL Management Studio here. So we'll see we now have one blog in the database. And if I go refresh my databases, we'll see it's created a table for me just based on the shape of my entities. So very familiar here. Really, the only difference we've seen so far from EF6 is the fact that I now override the onConfiguring method. We'll also see later it's possible to do external configuration, so I don't have to override onConfiguring in my context. If I want to configure my connection string externally, then we have ways to do that as well. And I'll actually cover that with a demo later on. I should also point out, just as a word of caution, in my code, I have my connection string in code. Obviously, that's not actually a good idea in a real app, especially if that has username and passwords in it. I only did that for the sake of simplicity. You can absolutely type configuration manager.connectionstrings and pull your connection string in from app.config. And that's what we do it in a real application. Now, one of the things about our new lightweight and extensible core is that we want to get better perf out of EF Core than we got out of EF6. One of the biggest bits of feedback we get on EF6 is it's just too slow in some scenarios. So I could show you numbers. I could talk about how it's faster, but I thought I'd actually do a demo and compare some EF6 and EF Core code. So let's close this one down. OK, in this project, I have got an EF6 and an EF Core model here. Now, this is an important thing. I can install both of these in a project and use them side by side. I've reverse engineered the model from AdventureWorks. So remember how I said we can have EF can either create a database for us or work with an existing database? For both of these models, I just generated the model from the database. And all I did was fix up some of the names so that the two models were exactly the same. And then I have this little harness here. I have a reset and warm up, so this just resets our database. And then I also just quickly create an instance of the EF6 and the EF Core context just so that everything's loaded into memory and jittered and we're good to go. And then I have a little helper called run test. If I go and look at that, it's down here. I'm basically just using a stopwatch to work out how long it takes to run each action. And then I print out the results and also do a comparison of the two. Okay, so the first scenario we're going to look at is just do a customers, not cultures. We're going to do a to-list on it. We'll run exactly the same code for both EF6 and EF Core, and I'll run it. Now the customers table has about 19,000 rows in it, so it's going to take, dude, go away. Very persistent errors list. It really wants me to know an error at the expense of actually being able to fix it. Okay. All right, so like I said, 19,800 rows, so it's going to take a little bit of time to come back into memory. So we see here EF6 took 680 milliseconds. The first time around, EF Core is taking 189. We then see caching kick in. You'll notice that caching is a lot more effective on EF Core, so we start to see even greater results once we've done the first query here. All right, let's get a little crazier here because, like I said, people never write to-list queries. They always write things a lot more complicated and then file bugs on why they don't work. So this isn't crazy, obviously, but it's a little bit more complicated. So let's run this one. Again, we're working against the customers. We're just doing a simple where, skipping a few records, adding a few order bys, and things like that. So again, we'll see similar results where EF Core is significantly outperforming EF6. All right, so that's query. Let's look at save. So I'm going to pull in some code here. We're going to create 1,000 categories. We're going to kind of naively just go and add them to the context using the add method to start with, and then call save changes. Now, anyone who's done any perf work on EF6 would know that there's actually some optimizations you can apply to EF6, so we're going to do that in a second. But I just want to show that the easiest code you would write, the thing that you're most likely to write if you're just starting with EF, is significantly faster as well. Again, we're looking at about an 80% increase here. You'll notice here that caching is actually making a huge impact on update as well. In EF6, we see a small change with the second iterations. In EF Core, we see quite a significant saving the second time I'm running these same commands. Now in EF6, we can do some crazy stuff here if we know what we're doing. So I know that I'm not making changes to any of the objects in memory, so I can switch off automatic change detection, like this. And then I also know that it's quicker, instead of individually adding these things, I can create an array of them. So we'll create an array with 1,000 slots in it, and then instead of adding them, we'll just go drop them into the array at the right part, and then instead of doing a single add, we're going to pull that down, make it an add range, and pass in the array that we created. Now, I could make these same improvements on EF Core, but I'm not going to. I'm just going to run it because I would much rather have simpler code that doesn't muck around with all this crazy stuff. And we'll see that the numbers aren't quite as significant as they were before, but even with this simple naive code, EF Core is still way outperforming EF6. Is that good? Come on. Now, don't be under the impression that I sat in my office for like 10 hours and ran a whole bunch of different stuff and pulled out the best numbers. These are literally like the first things that I wrote when I was putting this demo together. And I'm sure I could find numbers that are even more impressive in some cases, but I just happened to try these first. So this is literally the perf you'll get out of EF Core. I should also point out that's not RC1, which is our current public pre-release. That's our nightly builds. So RC1 won't quite give you that level of perf improvements. Anybody in the room ever used the metadata API with EF6? Got a couple of hands going up. Yep. I'm really sorry. You guys are probably scarred for life. For those of you who have no idea what I'm talking about, you're about to look at some code that will make your eyes bleed. All right, so for this demo, I have a very simple model. Again, we have an EF6 and an EF Core version of it. It's a blogging context that has blogs and posts. If we go and look at the classes, you'll see that I've mapped them to tables that are different than the actual entity names. So what I want to do is write some code that says, for this entity, what's the name of the table it's mapped to? So I've kind of stubbed that out in program CS. So I have this print EF6 mappings and then print EF Core mappings, and I have a to-do here to go and do this for EF Core. Before we do that, let's just go look at this highly intuitive code that you have to write for EF6. And I'm not kidding. I didn't make this abnormally complicated. This is literally the code you have to write to find the table name that an entity maps to. You know how I know how to write that? I go to my own blog and I look up the post and I copy and paste the code out of it. So instead of, remember down here in EF6, we get the metadata workspace via iObjectContext adapter, and then we get the object item collection, and then we go and look for get items of type entity type. Wouldn't it be so much better if we could just go, model might be a better name than metadata workspace, and then we could do get entity types. And then when we get here, we could say, well, surely this stuff's easy to look up because this is an ORM, so maybe I could do item.clrtype.name. And we could say that maps to item. Now, table's specific to a relational database, so I wonder how I get. For the currently active, and now I should point out here, because we can target multiple different databases with the model, the table name could actually be different depending on what database I'm targeting. So what I actually want to do is say, give me the table name that this maps to on SQL Server. I was looking for relational. We'll see that in a little bit later. OK, so let's just run this and see if this works. You'll notice, again, talking about performance, that the EF6 code is really quick to execute. And I'm trying to think of things to say while we wait for this code to come back and tell us what tables the entities map to. And the EF core one's really quick, right? OK, so yeah. Now, I want to level with you. EF6 isn't always that slow. It's slow because I'm not letting it create the database. So that's another important thing. EF6, to build the model, the quick route for building the model requires it to connect to the database. If you don't let it connect to the database, you see results like that. EF Core has no need to connect to the database to make the model. It knows that you're targeting SQL Server, and it will just build the SQL Server model for you. All right, let's go a little bit deeper, and we're going to talk about the extensible core. So the way EF is architected, we have DB context and DB set and all that stuff, and that makes up the top-level API. We have core services. This is stuff that applies to all data stores, like the state manager, et cetera. And then we have provider-specific services under the covers, too. So an example I talked about earlier was the SQL Server Type Mapper. That's a service that's specific to SQL Server. I also mentioned there were two scenarios for wanting to get at the services. One is to use them in your own app, and the other one is to actually go and replace them. So let's look at what it takes to actually get access to the services under the covers. I mentioned that we have this collection of services that EF is using, and that's stored in what's called a service provider, which is part of dependency injection. So I can get that thing. So on the DB context, I call this extension method called getInfrastructure. GetInfrastructure is just a way of kind of hiding away something that an object implements or it contains, but we don't want it to be in the top-level API. So getInfrastructure is an extension method you get if you pull in the Microsoft Data Entity Infrastructure namespace. So it's kind of hidden away a little bit, and it just gives you access to stuff that normally would have probably been like private or internal, but we want to avoid making anything private or internal these days. So we let you get in under the covers a bit there. And then if we want to get the mapper, now I could get the SQL Server specific one, but I'm actually going to say I want to get the relational type mapper. So the idea of mapping a CLR property to a specific column type is really specific to a relational database, because you can think if I'm storing stuff in memory or a Redis cache, I don't really have to worry about types of columns and things. So I'm going to say for whatever the active relational database is, give me the type mapper for it. And then we can come here and we can say, let's just get the type and print out the name. And then, of course, it'd be good to see what some things map to. So we want to get the mapping for the type of a bool property. And default type name is going to give me, if the user hasn't done any config on this property, this is the type you should use for this property in the database. Let's do the same thing for string too. Let's go run the app. So we're seeing here we're using the SQL Server type mapper because my model targets SQL Server. We're seeing that bool is mapped to bit in the database and string is mapped to envar char max. Okay, so this is stuff that I could reuse. I don't have to be using any framework. Now, of course, I was resolving this stuff from my context, but if I didn't have a context, I can totally just go and reuse this component without using the rest of EF as well. More likely, what you're going to want to do is change the way that our type mapper works. So let's look at replacing services. So here again, I have a very simple model, except on the blog class, I've introduced a property called metadata. Metadata in my domain model, I'm storing it as a string, but it's actually XML data. And so I want it persisted in an XML column in the database. Now, I do just want to caveat this demo. ADO.NET is completely capable of converting between XML and string. And that is why I'm going to be able to do this demo of storing a string property in an XML column in the database. We do want to allow arbitrary type mappings where you can write some code to say, this value comes back from the database, and this is how you convert it into my CLR object, but that's not going to be there in V1. But when there's simple stuff where I can just kind of let ADO.NET take care of the cast for me, then I'm able to do it by using the type mapper. Now, I've decorated this property with an XML attribute, and that's literally just something I defined. It's a marker attribute to say, this should be stored as XML in the database. Now, of course, I could go through my model, and I could use the Fluent API to map these and say it's XML data type in the database. But I would much rather do it this way. I've then gone and created a custom SQL Server type mapper. I don't want to re-implement everything from the SQL Server type mapper, so I've just inherited from it. I've created a new type mapping, which just says, you know, it's string, the ADO.NET data type is dbtype.xml, and it's called XML. And then I've overridden the thing that says, for this property, get me the type mapping. And we have it to do here. So we're going to say if it has the XML attribute, then just return the XML type mapping we created. This method here has CLR attribute. It's just a helper method that I defined, kind of works with the metadata and does some reflection to get attributes and stuff just to simplify things down a little bit. OK, so now we need to get our type mapper into Entity Framework. So we know from the previous demo that the thing that holds all of the services that EF is using is called the service provider. Now what I want to be able to do is replace that service provider with my own external service provider. So we're going to add a constructor here. It's going to take a service provider. And this is passing it to the base constructor. So this is going to tell EF, go and use this service provider with my set of services instead. And then we need to create one. So the first thing we need to do is build a service collection. You can think of service collection as a really bad name for service provider builder. We're going to add Entity Framework and then add SQL Server. So this is adding all of the services that Entity Framework uses. I was putting in the change tracker and all that stuff, and then it's adding all the services that SQL Server uses, like the SQL Server type mapper. Now I want to go and replace one of those. So I'm going to say add a singleton. We're going to replace the SQL Server type mapper. And instead of using the default one, we're going to replace it with our custom SQL Server type mapper. And then we can get the service provider. OK, so now I have this big object that contains all of the services I want to use, and I'm just going to go and pass that to my context. And then the code that I've written here, we're going to write the same code that we used before to get the type mapper and look at its default ones. And then I'm going to go ahead and create the database for the model and insert a blog. OK, so important to note here, we still get the same default mappings because string by default maps to nvarchar max. Our new type mapping only kicks in when the attribute is present. We're inserting a new blog in the database. And then if we go look at the database, we can see that we have the XML column there. And the data is stored as XML. And just to prove that, I will select it out, and we'll see it highlighted as XML there. So it's kind of easy to get lost in the details of this demo, but I hope what this brings home is that the core of EF is extremely flexible, and you really have the ability to get in under the covers and change the way EF works. All right, let's swap to something a little bit easier. We're going to look at using the same model. So I want to write the same code, and I want to go ahead and use that on multiple different app models or multiple different platforms. So another way of saying this. we'll close up this one. All right, the place I'm going to start is I have a note taker application, and I'm going to start with a UWP implementation of this. The other thing I have is a portable class library here that has my EF model in it. So I have a note. This is literally just like I'm sitting in maybe a session at a conference and I want to just scribble down a note. So I want to know what text I wrote in the note, when it was created. You can ignore the isUploaded flag for a minute. We're going to use that a little later in the demo. Then, of course, I have a context here. Now, this application is going to run on a device, and I want to store the data locally. And then later, we're going to look at syncing that data back up to a remote database. So instead of connecting to SQL Server like we've done for all of the last demos, we're going to say use SQLite. You can see I now have an extra extension method because in this project, I have SQL Server and SQLite installed. Now, for SQLite, all I need to do is give it a file name. EF will, if I just pass in a relative path, EF will take care of dropping this file in the right place for the right platform. OK, so now we've got that done. Let's go look at our UWP application. We have really two pages in the UWP application. We have a page that will display all of the existing notes in the database, and then we have a page for taking new notes. Let's drill into the code behind the new note page, and we'll see that when it's time to save, we create an instance of our note entity, and we need to go and save it to the database. So we'll create our note context. We'll pull up the notes DB set and call add. And then we'll call save changes. By the way, one interesting thing that we introduced in EF Core, instead of having to go through the DB set, you can actually just add directly to the context. And that way you don't have to, if you have some dynamic code that has, you don't know what type the entity type is. You know it's part of your model, but it could be anything. Or maybe it's an entity type that you don't have a DB set for. You can just drop it straight into the context, and EF will take care of working out what type it is in your model and where to add it. Anyway, that's not exactly pertinent to our demo. And if we go look at the existing note page, you'll see I've already implemented this one. We use a simple link query to pull the notes from the database, and we want the newest note at the top. Now, this could be running anywhere. It could be running on my laptop. It could be running on a device. It could be running on my Xbox even. So I need a way to create the database. I can't create it now because I don't have access to Fred and John and everybody's mobile phone while I'm developing in Visual Studio. So instead of running any commands to create the database, we're actually going to put some code in app start to say on the device, or wherever you're running, make sure the database is applied. Now, if I was using migrations, because remember, if this is a production app, I probably want to be able to incrementally push changes. I would simply call database.migrate, which is an extension method that would come in. I would have to use, it's an extension method, and it's only available because I have a relational database provider installed. Anyway, we're not worrying about migrations for this demo. So let's do that. We're going to debug on our local machine. So let's go ahead and run. We can take a note. Let's just say that EF7 is now EF Core. We'll save that. And then under my notes, I can see it all. So I'm using Entity Framework in a UWP application to talk to a SQLite database. Of course, because this is UWP, I can go ahead and run this in the emulator, and we'll see the same application running on the user's mobile device. Go and save that. And so we have EF talking to a SQLite database on a phone emulator as well. Now, UWP and Xamarin and all those things, they're like great. We love talking about new technologies. But I'm guessing a lot of you guys work for an enterprise. How many folks spend the bulk of their day working on UWP applications and applications for iOS and Android? Show of hands. Getting like some people putting their hands up a little bit. OK. My guess is that the vast majority of you probably spend your time working on stuff that looks more like this. Right? Yeah. So using the code from our portable class library, let's go back to our UWP application. And to save me typing stuff again, let's just copy this code. So our WinForms app has exactly the same model, literally the same code, the same code. And we'll paste it in here. And we'll run. Oops, wrong startup project. And it might not look as pretty, but EF-Core works on WinForms as well, which is hopefully more useful in your day-to-day employment. So. Now, for the next demo, the problem I have with this application is I'm taking all these great notes, but they're stashed away on devices and laptops all over the place. So what I really want to do is sync up to a central database. So for the next demo, we're going to look at taking the same model and using it to connect to multiple different types of databases. Now, where I want to stash things, I actually have an existing database here called NoteTaker. It's on my local DB, but this could be Azure up in the cloud. It could be a Postgres database running somewhere else. You'll see I have a note table here. And if I look at it, it's exactly the same schema that I've got on the phone or in my WinForms application everywhere. OK, so I want to dump the data into here. I don't really want to build a new model because this is exactly the same schema that I have in my local database as well. What we want to be able to do is externally configure our context. So let's go back to our portable class library, open up the context. At the moment, it's hard-coded to use SQLite, but what I'm going to do is introduce a new constructor that's going to take in DB context options and pass that down to the base constructor. Now, when I pass in a DB context options, that's actually exactly the same thing I'm building when I run the onConfiguring method. EF-Core, if we pass in an options, we actually still run the onConfiguring method because you might be doing some extra stuff in there that you still want applied in addition to the options you configured externally. But if you don't want to do that, we give you a nice little flag that you can use. So we can say, if the options builder already has some configuration done, then skip this code. But if it doesn't, then if nothing's been set up externally, then let's wire it up to use SQLite. That just allows all of our existing code that naively news up the context to continue connecting to SQLite. All right, so we have the upload button here. And what we're doing, we're connecting to the local database. We're finding all of the notes where the uploaded flag is not set. And then we want to go ahead and connect to our remote database and upload the notes. So let's start by creating an instance of DB Context Options Builder. So note that this type here, DB Context Options Builder, is exactly the same type, if I go and look at note context, that I have in onConfiguring. So it doesn't just look like the same API, it is exactly the same API. So of course, I can say builder, use SQL Server, and I already have the connection string. I mentioned that connection strings should come from app-config, which is exactly where this one is coming from. So then we can go ahead and create a new instance of our note context. This time, instead of using the default constructor, we're going to pull the options out of our builder and pass them in. db.notes.addRange. Interestingly here, I'm actually going to not attach copies of the notes. I'm going to attach the exact same instances of notes. So these are now attached to two contexts. And because they're straight up POCO objects, there's no interfaces, there's no state stored in them at all, I'm totally fine to connect them to two different contexts. Now, obviously, if I was using something like store-generated keys, I'd have to be a little bit more careful with this because I might have two contexts trying to write the key value back from the database. But everything here is generated client-side. So I'm going to go save changes. OK, once we've successfully saved to the remote database, we mark them all as uploaded and persist the flag back to the local database. So that we can see all this stuff working, I'm just going to go ahead and add in that column to the UI. So we're going to add a column to our data grid for the isUploaded flag. The scary thing is I had to relearn how to use the WinForms designer for this demo. I do those steps, it makes it look like I know what I'm doing. That took me like 45 minutes to work out how to do that. All right, let's go and run. OK, so we've got two notes here. Let's go upload to the central database. Uploaded two notes, and if we go here and run, we'll see that those notes are now synced up to the database. All right, so we're using the same model to connect to both SQLite and then a remote SQL Server database. Now, I do want to throw in one caveat here. I wouldn't, at this stage, be able to do this from the UWP application because SQL Client doesn't yet work in UWP connecting to an external database. That is something we want to enable, but if I wanted to implement the same functionality in the UWP application, I would have to go and use a service for the moment to do it. And that's actually another advantage of being able to externally pass in the DB context options like this. It means that I can create a context and share it between multiple applications. But if I am using a provider that doesn't work on a particular platform, then I can just deal with that provider-specific code in the platform where it actually does work. All right, I've got a couple more demos, so let's try and get through them quickly. Let's look at, oh yeah, everybody always wants us to generate better SQL from queries and from the update pipeline and everything. So let's look at some places where you're getting smarter about generating SQL. So the biggest complaint people have is that in EF6, if you go and save a whole bunch of changes in a single save changes, we run an individual command, so an individual round trip to the database for everything that you've modified, which you can imagine is extremely efficient. So in this application, I'm creating a blog context, same model we've been using for all the other demos. I pull back 2 existing blogs and I go and modify them. So I'm changing the URL property. And then I go and create some new instances of blog as well, in this case 6. So when I call save changes, I have 2 updates and 6 insert commands to run. I have SQL Profiler running here in the background. I'm just going to clear the log so that it's nice and clean. And then I'll go run this demo. We're done, and if we go look at the log, we'll see there's a single command that it ran. And we have our 2 update statements, and then we have our insert statement. And we're not just naively like appending together insert into, insert into, insert into. We put it together in a nice like value statement and pump out all the values for you here. All right. I didn't have to do anything to enable this. If I go and look at my context, see that I'm using SQL Server, and there's no other config done here. So we do this by default. Now, we're fairly smart about how we create the batches. We know what the maximum number of parameters. We know the maximum string length of a command. We know when it makes sense to break up based on database-generated values and things like that. But of course, you might say, in my application, I don't want you sending like a ginormous thing because I'm talking to a local database, and maybe I have some obscure scenario where it's going to be quicker to be a little bit more chatty with the database. So I can say the match back size, and let's just do 4, something quite small, and run the app again. Wait for it to finish, and then we go look at the log, and this time we'll see that it ran 2 commands. The first one has some of our insert statements in it, and then the other one, oh, I guess this one probably had our updates at the top there. Yeah, so this has the 2 updates and 2 inserts, and then the rest of the inserts happen in the following statement. Now, obviously 4 probably doesn't make any sense to set as a batch size, but you might pick something bigger if you're inserting large amounts of data. And of course, if you want to switch batching off, just a batch size of 1 will do that. Now, this is great when we're demoing against a local database that's running on an SSD on my laptop. We already saw that inserting and adding 1,000 entities is going to be quite a bit faster. We saw that in the second demo I did on performance. You can imagine if I'm on something and I'm talking to a database that's maybe, say, hosted up in the cloud, this is going to make a huge difference. I mean, locally, we were seeing increases with like completely optimized EF6 code. We were still seeing like a 30% increase on EF core. So let's see what happens if we go to somewhere that's a little bit more latent. So I'm on a conference network, and let's swap our performance application. Instead of connecting to my local SQLite instance, let's hook it up to go off and talk to a database that's hosted in Azure. I'm not going to scroll right and show you my username and password, but we have a database here that's hosted in Azure. And you remember our program, it's going through creating 1,000 product categories and then uploading them to the database. I'm going to try it with 1,000. We may have to drop back to 100. Let's go run this. This is where I wish I had a good joke to tell while we wait for the EF6 code to run. Obviously, 1,000 round trips. Azure tends to throttle a bit of the time, so yeah, not bad, hey? We'll wait again, the numbers get better. And then the second time around, often even better again. Let's see where we land. Yeah. All right, I got one more demo I want to show you. We're going to have to skip one of them because of time. But luckily, I saved the less impressive one for last, so let's do this one. OK, so if I have an application, one thing I often, oh, by the way, when I say the least impressive one for last, that's the one I'm not doing, not this one. So just setting expectations right. Don't zone out right now. Still better than Facebook. Keep watching. All right. Our application is going to do a search in a database. So I'm going to insert a search term, and we want to go and find blogs that match that search term. You can see I'm doing this at the moment by doing a string.contains on the URL. I probably want to search the title. I probably want to go and look through posts and see if any of the abstracts and the titles of that blog contain this term. That's really inefficient to do in a LINQ query. This is where it would make sense to use something like a database feature like full text search. And if I'm doing that, it's probably in a store procedure, or it could be in a table valued function. And so the database that I'm hooked to for this demo, if we go and look at it, has exactly that. Under the functions, you'll see that I have a table valued function called search blogs, and it takes a single search term, and it returns me a table with all the information from blogs in it. So instead of doing the where here, let's do a from SQL. And we're just going to run some SQL to select everything from. Now, obviously, I want to parameterize this because I don't want to go and do string concatenation because then I would be subject to SQL injection attacks. So I can go use this syntax. This is quite nice in EF. If I just say @p0, it's going to say the first parameter in my list. And then I can do I'm hesitant to use the analogy of string.format because it's absolutely not doing string format. It's doing proper parameterization. But it's going to take care of creating a parameter for this variable and dropping it in there. Of course, if I had more than one, I could do like @p1, @p2, and then just tack them all on the end. Nice, easy way. All right, let's just start with this. This isn't super interesting because you could do this in EF6 already. Let's start up our log again. I think I had it paused. Clear it. So let's look for cats because everyone loves cats. Oh dear. Oh, thank you. OK, it's working. As expected, EF is honoring my request to go and execute exactly this SQL. So I just want to, we're not adding anything to it yet. OK. Now, the problem in EF6 is as soon as I opted into raw SQL, at that point, I'm stuck with raw SQL. So if I want to go and do some ordering, well, then I have to go and write order by. And if I change my model in the future and stuff breaks, and I have all the problems as soon as I start doing weekly type things. The nice thing that we've enabled in EF7, oh, sorry, EF7. Put $1 in the swear jar, EF core. There's a lot of money in that jar, I'll tell you. So I can now start composing on top of this using LINQ. So order by. The other interesting thing in our application at the moment, we're not actually using anything other than the URL off blog. So there's no point pulling back blog objects from the database. So instead, I'm going to do what's called a projection to say, don't pull back the whole thing. I'm only interested in getting back the URL. And so now our return type, instead of being a list of blog, is now a list of string. So I can go and fix up our code down here. Let's run the application again. Let's look for cats again. And if I go look at the database, we'll see that EF Core is now smart enough to know that because I'm selecting from a TVF, and it can work out what's composable because it starts with a select, it is now composed on top of that using, and this is exactly the purpose of TVFs, is I can compose SQL around these in the database. So you can see that my order by isn't done in memory, it's done in the database. And my projection, I'm not pulling back blog ID and title and all that stuff. I'm only selecting back the blog URL from the database here. So by opting into raw SQL, I'm not losing all of the capabilities of LINQ. All right, let's just skip these slides. We changed the model building pipeline. I was going to demo it, but we don't have time. All right. Places you can head to next. If you want docs for how to use EF Core, then we have docs.efproject.net. Who saw the docs for EF6? Who's browsed around on like our MSDN site and seen what that thing looks like? Yeah, it doesn't look that great, right? So let's go back over here. Our docs now look way more beautiful. They look more like this. The other great thing is you'll see a little link up in the top here that says edit on GitHub. So our docs are now open source as well as our source code. One of the other links I gave you on that slide, when I hop back to it in a second, is the links to the source code from today's talk. Now, it's not just source code, so here's the repo it's going to link you to on my GitHub. So it has the completed source code here, so you can go and get exactly the code I just demoed and play around with it. But in addition to open sourcing our source code and our docs, I like to open source our talks as well. And so this repo contains everything you need if you want to go and take this same talk that I just did now and go and do it to your colleagues or your .NET user group or something like that. I've given you a trimmed down version of the slide deck with all of the build branding and copyright Microsoft removed from it. I've given you the starting point source code so that you can easily reset between demos. And then I gave you a detailed script of how to set up your machine to run these demos, what to do in between each run, and then step by step what code to write as you actually demo this stuff to people. Open source everything. All right, before everyone leaves the room, I just want to encourage you to please fill out evaluations, not just for my session, but for everybody's session. It really does help us do a better job. With that, I'm up the front for questions. Thank you very much for your time this morning. Have a good conference.